Nice, nice. Here we are for the second day of streaming the live development of the Block Magic hackathon. Guys, I'm so excited. Yesterday it was the first day of my life where I was streaming. Where I was live streaming, I discovered I like it, and actually working in live stream is much more, I wouldn't say efficient because it's a bit slower, but since I'm since I'm mm, like I'm doing everything live, I need to, like, everyone can see, so I don't like to do bad stuff, right? So I'm focusing a lot, and I'm like very straight, deep, concentrated on the development of the project. So that's why I want to do it every day, because it's good. It's good for me. But it's good for me, for the project, and it helps me to build to program with a more constant, like, it's like forcing myself to do to do something, right? So I got my smart contract hat from Lens Protocol. Maybe one day we'll do some hackathon on Lens. I know that Lens is on this hackathon, but is their technology is, like, their protocol is not really in the scope for my protocol, and especially we are just two people doing that. And I'm doing it full time, but Fante is doing it like part time, so we don't have much time to integrate many sponsors. Yeah, so let's start. Um, yeah, I posted it on the discussion channel in Chainlink Discord. This link. So glad if you join, and if you comment, and if you like, and if you subscribe to the channel. I will be so pumped up. And I have an announcement. I decided to I and Fante decided the name of this project. So the name of the project will be Buckle Up, written written this way, written in this way. Buckle up. Buckle up. I thought about buckle up because my personal idol Patrick Collins always says buckle up before every video, I guess. I mean, I don't know. It's a kind of funny name, and at the end I just want to have fun. So yeah, let me do something real quick. Just, let's get this webcam. I can just, yeah. How do I? Okay, maybe I know. Just trying to make it bigger. Full screen. No. Yeah, maybe this way is better. Nice. Cool. Okay, so recap. So what am I going to build? Building for Block Magic, I'm building a cross-chain liquidity protocol. Especially, we will build a liquid bridge. Buckle Up is a liquid bridge, meaning that people can bridge any token there, but the mechanism of bridging is not barred on the source chain and a mint on the landing or destination chain, but is everything is done through pools. So liquidity providers are just people who have money and deposit on these pools, and allows other people basically to use their money on the destination chain, and they are earning fees cross-chain. All right, so they are earning fees cross-chain, and this is a way to stake money, right, and earning fees. Basically, for in every bridge, people are earning fees, so it's like a social bridge, right? So and it's I think it's a very novel use case. I have to be honest, I didn't do a lot of research to see if this project has any other thing that is comparable to it, but honestly, I don't think so. With CCIP, this possibility is open right now, so I just want to try to do it, right? So let's see how it goes. So this is the project. I'm going to start to program actually. So yesterday DJ, how was it? Yeah, so yesterday we started building this cross-chain pool. I wrote all the kind of code documentation, the nut specs, and I started building it step by step, added some modifier, and then the constructor, of course, and then did the first function, deposit function, and then did the first unit test. So this is a test-driven development approach, which of course for me is, I cannot program in any other way. So what can I do today? So today maybe I'm gonna build the redeem function, like a basic redeem function. And then I want to integrate CCIP. And after I integrate CCIP, I want to try using a chainlink-local package. I think it's this chainlink-local. Yep, chainlink-local. That's great. Thank you, Chainlink. This is a great tool. Didn't try it yet. We'll try it live in streaming. Ciao Marco, grande. Thank you, Marco, for commenting. You make me so happy. Thank you very much. Latency in the streaming is not very high. It's normal latency. You can select in YouTube normal latency, slow latency, or no latency at all. But with no latency, I get live comments. But I have a lower quality of the video, so I just keep it normal. So it's like you have a couple of minutes of, I think 2 minutes of delay when you are commenting. I just saw the comment. Thank you, bro. Crypto Gallo. Yeah, this guy is a monster. By the way, guys, this is very important. I just forgot before starting. I just wanted to mention this thing, which is called urbe.eth. Urbe.eth is a no-profit community, no-profit Web3 community based in Rome. Where I'm based. I'm not from Rome, but I'm living here. And urbe.eth is a great community. It's one of the actually most known in Europe. We have like a vibrant community full of people building in Web3. And very important, we are organizing this hackathon, which is called where is it? It's Rome. It's Rome 24. It will be the second edition. It's one of the best hackathon out there because you get to have not too many hackers. It's very familiar, and you have very good sponsors, good prices, and you get to know everyone there. And if you are a protocol, if you are a sponsor, you can go there and get very good feedback comparing to other hackathons where you have way more people because you get to closely work with these people. And if you are an hacker, you basically have all the support that you need, like because you have less people, and then you are more if you have any problem, it's more easy for you to reach for help. And yeah, and then you have great food. We have great food, guys. Maybe this is the most important reason you should come. Maybe if my streamer career takes off, yeah, maybe I'm gonna be there doing some live streaming. Why not? Why not, guys? Who knows? Life is very weird sometimes. Okay, back to us. Buckle up. Buckle up. Yeah, so yesterday I did this deposit function. Today we'll do this redeem function, very basic. Then I will integrate ccipE, and then all the real problem will start there. I need to decide how do I want to deploy these contracts. Ideally, I should deploy these pools at the same time in two different networks. Yeah, maybe let's take note about that. How to deploy cross-chain pool. Yeah, in two different networks. Right? I should initially found this pool. Right? Should I found these pools? Should I found these pools initially? I should, because otherwise people can be subjected to sandwich attacks, which, as the word says, sandwich is like you have the bread, you have bread on you have bread on top and below the sandwich, the content of the sandwich. So this means that you, in translating this in blockchain, you have some transaction happening before you do something, and then some transaction happening after you do something. And this is, in this case, is some practice that hackers can do to still, yeah, to exploit a contract. Okay, so back to us. Just let me do something. Yeah, nice. Yeah, my face. Okay. So should I found this pool initially? Maybe yes. Maybe not, because it's just, you know, my focus now is making it work. Then I can improve it. Okay, what was the other question? Okay, for now it's fine. So let's go on and build the redeem function. So the redeem function is very loud. Just 1 second. Okay, I'm back. Hopefully now I can start. So redeem function. The redeem function give back tokens to LPs and burn LPT check if the LP is a LP, of course. Yeah. So function redeem, well, is external, and then doesn't return anything. Okay. What should it redeem? The amount 256 LPT amount, right? So LP gives LP input amount of LPT, contract transfer underlying to LP. Okay, should check if the LP is an LP, of course. All right, so should follow check effect interaction pattern. Okay, so checks. What are our checks? Checks. LP. Where is it? LP is an LP. Is LP an LP? How do I check this? I can do some check on the ERC20 token, right? Maybe I like to do modifiers, guys. I'm like this. I'm sorry, but I like to do modifiers. This is more readable, I think. Is LP, is user LP, liquidity provider, something like that. Yeah. So how do I do that? If message.sender message.sender no if balance of message.sender is greater than 0. Sorry guys, it's very loud. Just 1 second. Okay, I'm back. What is this? Okay, is user liquidity provider. Is balance is less than 0, revert, and I will do another error, cross-chain pool, not LP. Sorry, you're not an LP. You just can't do that. Okay, so if balance of message sender is equals 0, I do this because then I will have an error. Not an error, but a warning in the compiler when I do strict equality to 0. So if balance of message sender means that balance of this contract, which is the LPT, basically, this contract is an ERC20 here, and it gets minted to users. Yeah, cool. Where is it? Yeah, here. Okay, so is liquidity provider. If balance of basically equals 0, it's impossible to have less, but who cares? Revert. Let's get this. Where is it? Redeem here. Yep. Okay, and then LPT amount. Okay, I don't think he needs to pass the token in. Okay, so the contract task transfer underline to LP. Maybe I want to do a function that calculate LPT. This function calculates the LPTs corresponding to the amount of underlying, right? LPT, let's change this name, calculate LPT. Where do we have this? Calculate LPT, okay. Let's change it, calculate LP in exchange of underlying. Okay, here. Okay, maybe I can make it a little bit better later on, but okay, this closes. Okay. So why am I doing this? Because this is calculating how much LPT I get if I deposit the underlying token. Now I want to do basically the same function and to understand how much I should get if I deposit the LPT, right? Okay. Nice. That's cool. That's also, that will be also a public function. So calculate underlying in exchange of LPT cap LPT, like that. So amount of LPT, this is public, okay. Calculate underlying in exchange of LPT. So ideally anyone can also call this to understand how you know, how much it will get. So not spec, yeah, this way. How is it? Why do I have this? Oh, okay. Not spec. So notice calculate the amount of underlying token user get, well, LPT get in exchange of the LPT param amount, the amount to exchange. Okay. So the formula, yeah, we'll maybe do this, copy this, repetita juvat, and okay, cool. What do I have here? Okay, just to, okay. Underlying exchange of LPT. Now calculate the amount of underlying token LPT. The amount of token LP get in exchange of LPT tokens. Okay, more is better. So how would I calculate this? So to get one LPT is this. So to get total cross-chain LPT, is this correct? So this, let's go to our thing here. to draw it, buckle up. So, okay, 1 LPT equals, we said, total cross chain dot cross chain what underlying on total cross chain LPT, right? So if I have one LPT and I have 200 cross chain 200, the underlying, maybe this is 200 USDC. Oops. And I have total cross chain LPT, maybe also 200, I don't care. Means that so I should calculate the LPT, right? No, I should calculate the total, calculate underlying. Okay, so $200, okay, equals 1 LPT times 200 LPT, right? So one of these guy equal 1 LPT times in this case it's like this, right? In this case it's just 1. But this means that 1 underlying equals total LPT on total underlying. Makes sense? Yeah, just wrote it here just to reason out loud. Okay, so the formula is 1 underlying equal total cross chain LPT on total cross chain underlying. Okay, so in this case we didn't integrate the chainlink CCIP yet, so yeah, so okay, cool. We didn't implement CCIP yet, so we just do it on this contract. Okay. So total cross chain underlying amount, I get this, leave it like that. Total cross chain LPT amount, if return the amount, that makes sense. LPT amount, and this I will call it underlying amount, equals, we say total cross chain LPT is the other way around. So total cross chain LPT on total cross chain underlying, right? Okay. Okay, nice. Okay, cool. Is it okay? It should be. It should be. So in the test, I did subsequent deposit, right? And this is still working. Nice. Redeem. Calculate underlying in exchange of LPT. Underlying in exchange of LPT in redeem. So basically, I will do the same thing of above. LPT amount. All right, and then this is uint 256 underlying amount equals this, and then want to emit another event. So emit another event. Let's emit redeemed. Redeemed. So address, index, liquidity provider, and yeah, maybe I will just maybe I will just do this LPT amount burnt and underlined amount, maybe this. Okay, all right. So emit. Okay, so emit redeemed. This is message sender, and this is the LPT amount, and this is underlying amount. Cool. So this is our effects. So checks. This is the check. Oh, yeah, I will do it later. To do, make it non-reentrant. Haha. Haha. Make it non-reentrant. So this is very important. This is very important. So especially in this kind of functions, the withdraw function, you have a problem of reentrancy, which I will explain in a few minutes, or maybe I will explain it now. But basically, you can call recursively this function to drain all the funds of the contract. So you make it non-reentrant, meaning that you are locking the function, so you cannot call it recursively. This happens also when you don't respect the CEI pattern. So if you respect this pattern, usually you are kind of safer, but you should have here a modifier like non-reentrant, but also you can use OpenZeppelin library. Maybe I will go in depth into it later. So check. This to do make it non-reentrant, and then this is the check, the effects, and then the interaction. Interaction should be contract should transfer, okay, underline to LP, and also contract should burn LP. Yeah, this function is very tricky also to implement with CCIP and cross-chain. This will be the real value and the real challenge of the sorry. Okay, this will be the real challenge of the project and the real value of the project, because we are doing we are basically trying to do cross-chain fees. Okay, nice. Cool, let's go on. So interaction, transfer underlying to LP. So underlying amount, So save, no, immutable underlying token dot save transfer token. Yeah, I'll just not sure about that. Why should I pass the token? Okay, to message dot sender and value. Value is underlying amount. Yeah. Exactly. Why? I don't know. Okay. Underlying save transfer, and then so transfer underlying to LP, and then underlying and then barn LP, and I will just call barn account msg dot sender value LPT amount to barn. Nice. Okay. Now non-reentrancy. Let's see this library in yeah. Okay. Cool. Let's see this library in OpenZeppelin. Let me look for it. Oh, I'm curious. Let's see this reentrancy attack. Okay, this is the contract to exploit it. Maybe they provide this contract for auditors to have like something that they can use to make the proof of code. Okay, utils reentrancy guard. Nice. So this is an abstract contract that helps prevent reentrant calls to a function. Inheriting from reentrancy guard will make the non-reentrant modifier available, which can be applied to function. So you inherit from this contract, and then you have this modifier that you can use in your function. And then this happens basically on the first call to non-reentrant, status will be not entered. If status entered, revert, right? So this is the modifier. It sets the entered status, and then at the end of the function, then you execute the function here, and at the end of the function, the status is not entered. So the function is callable again, right? So cool. Nice. Sorry, guys. Okay, so I'm going to import this in my cross-chain pool. Cross-chain pool, where are the imports? Here. So importing this from reentrancy guard. Let's see the relative path. Sorry, guys. This is an allergy. Allergy period for me. I don't know about you, but for me spring is very like harmful. No, it's the wrong path. Contracts, so utils, maybe it's this. Works. Yeah, nice. So my contract is ERC20 reentrancy guard, and we'll use it we'll use non-reentrant. Note that, I'm placing this non-reentrant first because this is like the first thing I want to have when I'm calling this function, right? So as soon as anyone calls this function, I'm just making it non-reentrant, so you cannot call it recursively. The first thing I'm doing. Okay, cool. I did it. So let's write better not spec. Yeah, redeem. Okay, redeem. Okay. So notice burn amount of LP and give and transfer amount of underlying tokens to LP. Okay, param LPT amount, the LPT amount to burn, Mr. Burn. Okay, this is the param notice. Okay, I think it's enough. I think it's okay. Okay, nice. So now that we did that, let's try this out, and let's test it. Okay, so let's do some modifier deposited public. So I will use this modifier in my tests. Yeah, I don't know if it's view. What did I do wrong? What is this? Why do I have this error? Expected this function. Should it be like here or what? I don't know. Okay, so deposited, I want to basically copy this. Deposit, okay. Don't need this. And here, actually, I can use it public view deposited modifier deposited. Okay, maybe I don't. Oh, yeah, because it's a modifier. I don't need the modifier, the visibility keyword. So, okay, deposited. Okay, so test for deposit, public deposit. You can just delete all of these, balance of LPT, and this should work, right? Let's test. Forge test dash empty test first deposit. Failed because I have an error. What is the error? Oh my god. Okay, yeah, I need to put this. Yeah, it passed. Nice. So the subsequent deposit. All right. Maybe I will do it better. Okay, but just do function test redeem public. So I need to call redeem, of course, deposited. Of course I need to call redeem, but what else do I need to do? I need to impersonate the liquidity provider, start crank LP, and then I want to burn thinking about other things. I think maybe I should have a function to get the minimum amount of tokens, underlying tokens I want back, something like that. Well, should I don't know. I actually don't know. So start crank, call redeem, then I need to basically approve. So underlying, no, it's not underlying, it's like cross-chain pool. So here I'm approving LPTs, right? Cross-chain pool dot approve, and then the spender is, well, cross-chain pool. Don't know if this makes sense. Maybe I don't need to approve. And the value, let's do like dummy value, uint 256, value to burn equals 118, right? Because how much did I deposit? 118. Okay, let's do 1E17. Let's see if this works. Okay, approve this, and then cross-chain pool dot redeem value to burn vm dot stop prank, and then assert no cross-chain pool. Okay, assert equal, but first let's check the balance. So what is this? Okay, the address, I should put here the address cross-chain pool value to burn. This makes sense. Okay, so now I want to check that the balance of LPT is burned correctly. I will be happy just with this for now, and that don't revert, right? So if it goes here, it means that it didn't revert, and the balance, at least the burning of the tokens happened correctly. I'm not sure about that. I don't know why I'm not sure, but I'm not sure. Double check. So the balance of LPT. So cross-chain pool dot balance of LP, or maybe it's address. No, LP is already an address. Okay, so the LP equals deposited. How much did they deposit? Okay, starting deposit is 118, so it's starting deposit minus starting deposit. Why don't I have this suggestion in my code? Starting deposit minus value to burn. Let's see if this works, guys. No, it's test redeem. Test redeem. Okay, test. Okay, this is working. Okay, I'm happy with that. I'm happy with that. Okay, cool. Okay, nice. So, what else? Cool. I got 3 views today. Nice. Thank you guys. I think I'm gonna take a little break and I will come back and I will start implementing CCIP live. Of course, I didn't see, I mean, yesterday we checked together how to use CCIP, but today I'm gonna make it serious. Okay, so little break and then I will be back. Thanks. See you later. Okay, I'm back. Okay, let's try to use now CCIP, guys. This is the most difficult part because it's not straightforward. You need to integrate CCIP. You need to install a set of tools, and also, yeah. Apart from the smart contract coding, the testing is something which is obscure to me. So I'm gonna look into it live. I didn't look into this chainlink-local before. I didn't know anything about it before. Let's see how can I do that. Let's see how I want to build this CCIP system. Oh, there is some this is stop, please. Okay, nice. So let's first think about how I want to design ideally the CCIP system. So we say that I have 2 blockchains, Avalanche and Base, and I want to connect them through CCIP. And this is clear, right? This is we all agree on that, right? So big avalanche here. I'm not sharing it or what? Yes, I'm sharing it. Okay. So I have an avalanche here. I have base here, and I have this small CCIP here, which is doing the job of connecting those chains. How do I want to build this system? Let's think about it. Okay, guys, I'm thinking about it. Maybe I'm gonna change my mind later on. Let's think out loud. So deployment first. Deployment. So how do I deploy this? Ideally, deployer deployer should deploy pools at the same time. Yep. So maybe I can do something that starts from one chain, deploy first on the source chain, and then deploy here first, and then deploy here. This implies that I have some bytecode. Can I send bytecode with CCIP? I think so. Depends how big it is. There is some limit. Okay, maybe there is another way which is more approachable. Maybe I can just, okay, there are different possibilities, right? So again, first possibility, send, so not send, but deploy on Ava deploy on base. Second possibility, deploy on Ava, send CCIP message to base to deploy on base. This will be like these two steps, and this will be deploy in Ava, send CCI message to base, and deploy on base, right? So second possibility, first possibility. Okay, also I want to do this permissionless, should be permissionless. Should be permissionless. So I want anyone to deploy new pools, because this way will be way more fun, and this way I could actually give life to a protocol. So a protocol is a set of actions that are like fixed sets, and you have an exact amount output if you run the protocol. So making the to make a good protocol, I want a good way to first deploy these pools. So how can I do it? Maybe I should get the second approach, and maybe maybe what can I do even harder? Well, not harder, it's not harder. Like a consequence of this is that I need some factory manually deployed on many chains. So these factories just do like on base, on Ava, on RB, right? And so on and so forth. So these factories, let's draw a factory. like it. I like this. This is my factory. I don't have brown in this. Oh guys, I just figured out you don't have brown in this color scale. Oh yeah, you have it. Okay, this is brown, this is factory. Sorry guys, I just love this this app. This drawing app is great. Yeah, save items. I love it. So I have these factories. I have this factory in any of these. Okay, and this factory then deploy basically pools. And guess what? I have the drawing of a pool, right? So what happened here? Let's do another page. Copy. What happened here is that I have these, and let's say I'm a guy who want to make this that want to create a new pool. So I'm like some liquidity provider that says I feel very confident in this protocol, and he feels really confident in this protocol, and he says, hey, let's make money. Let's deploy a new pool pair. So he needs to deploy a new pool pair. So he needs to choose to networks, right? Networks. You need to choose two networks, and yeah, and then you need to my writing is terrible. Networks. Sorry guys, I'm picky sometimes. To networks, and then of course we'll start from a network from one, like he choose base and avalanche, and he can choose to start from base or from avalanche. We'll start from one of the chosen nets, right? And then what he does is he send a message. He trigger a transaction where he or she deploy on the source chain and deploy on the destination chain. But basically he just will send a message with CCIP, which will call a function on the other network, right? So will be more or less like this. We'll call factory, we'll call the factory, and then the factory will deploy pool on source, and deploy pool on source, send ccip message on destination chain, and on destination chain deploy pool. Right. Okay, for now will be enough. Ideally, the user should send a message, should actually transfer tokens, should send some data and transfer tokens to the destination chain. But in this case, I don't mind. I can do it later, or the liquidity provider can do it manually afterwards. This is actually a pain point. Because my objective was to not do that, right? To just don't transfer token, which may be more expensive, and more slow. But maybe we can consider doing it just once. I don't know. Let's start this way, and let's build a basic factory first, and let's build a basic factory, and let's deploy this, and let's integrate the factory with CCIP. So the first contract that we will integrate CCIP in will be a factory. So ideally, the factory will be a message sender and a message receiver, ccip receiver, and I think it's enough, right? Don't remember. Okay, let's build the factory, guys. Plot twist. I thought I was just going to do the pools, but actually we need a factory. We need a factory, guys. Okay, let's do this. So. Cross-chain pool. Okay, we just did the basic things. Fair enough. Maybe in the pool we want to add apart from the token, we want to add some other parameters in the storage variables, which can be the allowed chain, right? So if you remember, yesterday we went to the CCIP tutorial in Remix, and we were allowing the cross-chain, the other network. We were allowing to receive, we were allowing the contract to receive messages from a selected network and from a selected sender, right? We will do it later. Let's focus on the factory. I will just copy paste this, and I will just call it cross chain. Okay, well, just pool factory. I'm gonna leave it here, and I'm gonna maybe don't need this. Okay, not spec. Yeah. Let's rename it pool factory. It's not an ERC20, probably it's not reentrant. This I don't think I need this. Let's do it super basic. Maybe I will need later. I'm gonna re-import them, but for now it's not needed. Okay, I can delete this. I can delete this. I can delete all of these. Yeah, I can delete them. Yep. And then the constructor, of course, I need the constructor. I'm gonna come back later to it. And then delete this. I just can delete deposit and redeem, and I can delete also all of these. Yep, deleting everything. Okay. This can delete. Yep. Cool. Okay, let's start from the constructor. So, the errors. Let's delete this. So, no, let's start actually from NatSpec. So, notice this contract deploy simultaneously. You write it this way. Yeah, I think so. This contract deploy simultaneously pools on two chains, on two networks. Okay, enough for now. Yeah, no, not enough. It should get us in the constructor, in the constructor, the networks. No, the constructor. Yeah. How can I do it? Maybe I can hard code the networks. I can do some function. That's a good point. Okay. I'm thinking about mapping the allowed networks in the contract. Don't know if I can do this in the constructor. No, maybe I will add a function to add the allowed networks. Okay, there should be a function to allow different networks. Okay, it inherit from chainlink-CCIP contracts, just to do check which we'll do it in a few moments, and then okay, has an external function that anyone could call to deploy a cross-chain pool. Let's call it like that, or like a pool, cross-chain pool pair. Let's call it like that for now. And then lastly, should use clone pattern. Yeah, this contract should deploy it. Okay. Should use clone pattern to generate. Yeah, but the clone maybe it's not very comfy. No, or I don't know. Oh yeah, I should modify that. Yeah, so I want to use the clone pattern, but to do so then I need to modify the cross-chain pool to use the initializer. Using the clone pattern will be cheaper, probably. But for now, I will to do. Yeah. For now, we'll just I will just use the new keyword. Yeah. Okay. Contract pull factor. Yeah, pull factory. Let's import our cross-chain pool. Cross-chain pool from this cross-chain pool.sol. Okay, and the constructor. What does the constructor have? Should does. Okay, I'm not putting any owner here, or maybe should I be the owner? Should the deployer of this factory be the owner? Yeah, definitely. Yeah. I will own this. I will own this because I want to be the only one to add networks to these factories, right? So I will own this. The deployer is the owner of the contract. Nice. So pool factory. Let's import ownable from OpenZeppelin. Utils, multicall. What is it? Governance. No. Access. Ownable. Yeah. 2 steps. What is this? Contract module, which provides access control mechanism where there is an account, an owner that can be granted exclusive access to specific functions. The initial owner is specified at the deployment time in the constructor for ownable. This can later be changed with transfer ownership. And ownable? Okay, we'll just use ownable for now. Just did some mess. Yeah. Sorry guys, just some technical issues. Sorry. Nice. Okay, so can you actually see the screen? Let me know. Should be okay, right? Maybe I can make this a little bit, I don't know, maybe I can just do this. Now it should see better. Okay. Okay, cool. Only owner. Ownable, what is it? Here, ownable, relative path, and then here doing this, yeah. Access ownable.sol. Yep. Is it okay? Yep. Cool. Ownable. So I have an ownable. So this is pool factory is ownable, and then the constructor ownable message dot sender. for now. So this is actually like we will have what happened here. Why do I have this? I don't know what's going on in this screen. Why is that so? Why you see it this way? Let's refresh this. Guys, my Google Meet just okay, now should be okay. This okay. Is it cool? Sorry guys, some technical problem. I'm gonna resolve this. It's not easy. Yeah. Now you see that. Okay. Oh, come on. Okay, nice. Okay, we did it. Nice, we can start again. So okay, now should be okay. Perfect. Okay, so we have a networks, basically an interconnected networks of factories that are connected through CCIP. And ccip connect them all. In couples, so they are connected. They are not connected. Yeah, they are connected, but not actually total interconnected. They just connected in couples, right? So this is kind of wrong. It looks more like this. It looks more like this. Right? So, but it's like more, just for you to understand, it's like a group. These communicates just between themselves, right? Those other two guys communicate between themselves. Those two guys communicate just between themselves, and those oh, it's too dark, between themselves. Okay, so in the factory I need to decide, so we said it before, right? You need to choose two networks. So you need to choose two networks. So okay, so we need the function choose networks. Choose networks. Well, maybe this is internal. Choose networks. No. Well, okay, wait. We need a function to actually deploy, right? So deploy cross. Well, let's call it ccipOol. Deploy cross-chain pool, and this function should select two networks and then deploy pool on this network, on this meaning on current network, and then send ccip message and to factory on other networks, right? And yeah, on other networks, and then as a side as an effect of this, of the previous action, on other network should be deployed the correspondent network. So this deploy should be the starting point, right? And then what happened is that you have let's get this copy. You have this, right? Copy. Oh no. Oh my god. What did I do? Okay. Okay, that sounds okay. That looks good. Okay, so I have these two factories, and so deploy, make it with here. So I call deploy, how did we call it? Deploy ccpool, right? So our angel ccip angel deploy ccpool ccip here and here. So this is step one, right? This is this receive a call data and call which function? Should it call deployCCpool or should be like this is something I need to really reflect about, right? So okay, so here this ideally will have this will have like receive and receive will trigger new pool, and then at the end of new pool another message here, new pool, another message here with the address of pool. So, and here allow sender and this will be enough. This will be enough, right? Do we have, oh, we cannot do that. We need to do manually. I don't know. Unless we can kind of forecast the address of the deployed contract. Let's check this. How to? So we can use create2 code, but can I do it cross-chain? So with create2 code, you can deploy, well, you can know the address of the contract before deploying it, right? But will it be valid cross-chain? How to use create2 opcode to deploy to forecast. Okay, opcode opens up using create2, deploying smart contracts using create2. Okay, so this opcode gives the ability to predict the address where a contract will be deployed. Okay, so this is explaining what create2 is doing. So it's giving the ability to predict the address before deploying it. So here, maybe in deploy contract pool, in deploy ccpool, I can do something very interesting, which is like this function should also predict contract address. I have the feeling this is not going to work, but I will try anyway. Predict contract address and allow it before sending message, right? So once we have the message here, we can, oh, no, wait. Okay, this is not needed. This is not needed, guys. But it was fun. Because actually what I will do is deploy these pools on 2 chains. So this pool will be deployed on many chains, and they will be already they will have already the permission to send and receive messages to the other chains, to the other factories. So we are talking about factories that I will deploy manually just once, right? So I will deploy this factory, then deploy this factory, then then in this factory allowing the contract to receive messages from this factory, and then we'll do the same here. Okay, so this will be done manually, but the create to op code is interesting. Maybe I can use it later on in the project. Maybe, maybe or maybe not. Maybe I don't need it. But it was going to be something crispy, guys. Okay. Okay, let's go on. Let's go on and let's inherit. Let's write this here. So send CCIP message to factory on another network should be deployed the correspondent pool. And yeah. There should be a return message. No, maybe what can I do is, okay, maybe, okay, the point is that I create the pool and I create the pools, and then I need to allow them. So this, oh shoot, yes, this made the sense what I just said about the, I'm so dumb. So yeah, because we are talking about pools. So we have the factories. Of course, they can receive messages, right? But I want to allow the pools to communicate between them in an easy way. I don't want the user to do many stuff. I just want them to call one function on one blockchain, on one network, and then having the pools deployed, right? And I want to have the pools deployed in a way that they can communicate each other natively in the protocol. Okay, this is challenging. I'm gonna do this, guys. Buckle up. Yeah, I need to get some little break. We'll come back in really a few minutes. Okay. Buckle up. Okay, so I'm going to do this. I'm going to build some way to deploy two pools on two different blockchains, and yeah, and allow them to communicate between themselves. Let's see if I have some help, some example boards. Mr. Boards, want to keep this open, and then let's go to CCIP documentation, chainlink CCIP, guides, transfer tokens, defensive example, don't mind, off-chain, checking CCIP message status. This is something nice, by the way. Transfer USDC, send on with data. These examples. Cross-chain DApp and tools, tic-tac-toe, name survey, DeFi lending, liquidation protection, cross-chain NFT. Let's see if DeFi lending has something. Cross-chain DeFi lending and borrowing. What is CCIP? It's nice. Use case description, sender contract, protocol contract on Sepolia. Yeah, this is doing something. Don't like this. I don't like this. Come on, guys. You can do better than this. You can do better than this drawing. I cannot even read. Use case setup. Configuration. To green. Okay. Okay. Assume you will follow without modification. Environment variable. We don't use an end file. This is so good. Private key, blah blah blah. Yeah, they manually deploy. Let's ask on Discord. Maybe you cannot do that. Support. Can I deploy two contracts on two networks using CCIP? No, it's not. Okay, let's do this. Let's manually deploy yeah, I'm just thinking while I'm doing this, right? So I just didn't prepare anything, so sorry if I'm like, sometimes I'm like flashing. Okay, so I need to make this CCIP contract. Okay, so let's do this. Let's see what's inside here, protocol and sender. So let's assume this is a sender. CCIP receiver. CCIP receiver. Did I already install the CCIP in my library? Open Zeppelin, chainlink-local, CCIP, yeah. Okay, so I can import this. Import CCIP receiver in my pool factory. See, no, in fact, CCIP receiver, let's see. CCIP, contracts, foundry, SRC, nope. SRC, CCIP, I don't have SRC or what? Okay, contracts, SRC, V8, and then CCIP, of course, and then applications, and then Okay. CCIP receiver. Copy relative path. And full factory here. In my foundry.toml, did I map that? No. So let's see how they mapped it. No foundry. Yeah, they're using hard.dat. Okay. Okay, I don't mind. So assuming that this is the thing, I want to add another mapping, and I will call it get this. I will call it maybe just CCIP. CCIP. I don't know if this will work. I'm very bad at doing mapping. So CCIP equal lib CCIP and then applications CCIP. Okay, should work. Maybe, I don't know if this will work. So CCIP, so ideally the path will be CCIP slash this, right? Slash this. I don't know. Let's see. Nah, CCIP. No. Let's try to remove this. Remove this. You can't find it. Foundry CCIP slash problem with mappings. What did I do? Okay. CCIP application, blah, blah, blah. Not even getting there. No, I have this error. Oh, come on. I have a better idea. Let's go to package.json here and let's see. I for sure have something chainlink contract CCIP. Yeah, let's find this and see if chainlink yeah, this, and we have some guide, build chainlink, Apple Silicon, Docker build, local chainlink node. No, this is not what I'm looking for. Even though this looks good, but no. How do I use this in Foundry? There is no guide with that. Guide, chainlink CCP, getting started. No. It's not good. CCIP contracts. Oh, now worked. Wait. What? Now it's working? Yes. Okay. Okay, I solved it. I don't know how, but I did. Nice. It's working. Now I have this. Oh, sometimes I really don't like Foundry. I have this problem all the time. CCP application, CCP receiver. Maybe it's just a problem. Maybe if I try to close it and reopen. Will be enough. Okay, looks good. So this guy is CCIP receiver. Oh, now we need to understand what CCIP receiver is. Let's go here and check. Okay, CCIP receiver. Base contract for CCIP application that can receive messages. Nice. The interface I need to check through supports interface. Okay, it's an abstract contract, so it means that something. Okay, override this function. Nice, CCIP receive. Okay. Need to override this function. Okay. In your implementation, plumbing. What is this? External virtual. Override only router, CCIP receive. Okay. So I will override this and then I will call CCIP receive. And in this example, how do I send the message? This is the sender. Let's see, the message sent, send message, destination, blah, blah, blah. Okay, so anyone basically can send a message. You don't need to yeah, you don't need to inherit something. Yeah. Client, what is client? This is a library. Let's see. Okay, I don't mind. Protocol. This is receiver as well. Message sent, and this also can send message. Okay, CCIP receive. So they basically override this, right? And they do they do things in here. Okay, I understood. So I want to be free. So I'm inheriting from CCIP receiver. So first thing I will do is internal override. Okay, internal override. So here now comes the juicy stuff. So notice inherits from ccip receiver and allow the contract to receive message. Okay, messages from other factories. Let's see. So message ID, search chain selector, fetch the search chain identifier, sender address, depositor address, any to avian message. Not sure about what this any to avian EVM message is. This is nice, by the way. Collect token transferred. Maybe I don't need to allow do I need to allow specifically allow the contract to receive message from other chain and senders? Because here I don't see anywhere that they are allowing specific blockchains, right? Send message, this is commented or what? Why is this light blue? Get last received message, withdraw token. Yeah. Let's see. And here in ccipReceiver, should indicate whether the contract implements any to EVM message receiver. Support interface. Okay, wait. I'm not understanding this. The interface ID to check. Supports interface. Let's see, what is this? It's here. Okay. I'm not sure why in the documentation here I had to allow source chain. I should allow list the destination chain. What? And the source chain. Are we sure about that? I'm not sure about that, because here is not, I mean, Where is it? Protocol. Allowance. Withdraw. There is no allow keyword here, and protocol sender. Received message. Send message. This building the message here, router client. Okay. This is receiving the message. Okay. I have no idea. I'm gonna ask to. Should I always should I always allow list source chain and sender in my ccip receiver contract? Because I saw some example where you did it and other where you did not. Okay, I told you this is getting crispy. Yeah. Nice. I have 5 views, guys. So happy about that. Okay, this is getting crispy. How can I do it? Maybe send arbitrary data. Like this explain exactly what you need to do, but doesn't explain why. Deploy your contracts, okay, and then enable your contract to send CCP message. Is it like something just for this contract? Let's see, withdraw, receive, get last received message details, build CCP message, and then CCP receive. Allow listed. Okay, now I see. Okay, you can optionally do it then. Cool. You can optionally do that, but if you don't want to do that, it's cool. This is a challenge now, because I mean I can skip this part maybe for now to make it easier. Otherwise I need to use this create to opcode. You know what, I will just skip that for now, and then I will just allow my factories to receive messages from whoever, and then once I have a basic thing, I will go over it and will refactor it. Okay, so cool, that's cool. So ccipReceive to do should allow just a smart contract to receive messages, well, to send messages here. Okay, ccipReceive. Let's see how to implement this. ccipReceive. we are storing the last received message ID, the last received text. Okay, message received. Okay. Last received message ID is can copy something from here. Set variables. Last received text. No, maybe I don't mind it. Maybe yes, just for now. And then yeah, let's do the getters. Withdraw token. Yeah, that's good. That's good. Just do it for now this way. Then message received, of course. Message received. Emit message received, and then this is an event, and it is event. So I have okay. The unique ID of the CCIP message, the chain selector of the source chain, okay, and the address of the sender from the source chain. Okay, so in this CCIP this is working, but it's giving me problems. I'm gonna fix it later offline. Yeah, so ccipReceive, this is not used. Okay, memory message is not used. Client, this client, where is it coming from? ccipReceive, let's see, 1 second. ccipReceiver, client. Is this doing? So, okay, this is doing, it is a library doing a bunch of stuff. Okay, some struct, some AVM to any message, receiver, data. Nice. So pool factory here. Did the ccipReceive. So we say that on the receive, it should deploy a new pool. Yeah. So in okay, it should deploy a new pool. It should deploy a new pool here. Well, in this network, yeah, in the network where this contract is received. Yeah, okay, so CCP is okay, is nice. The only thing is that is a lot of stuff. So developers have can have some difficulties at the beginning because it's a lot of stuff to understand. Okay, so this is the ccipReceive. This let's do this to do should deploy a new pool in the network where this contract is. So deploy pool, and we have deploy ccpool here, and then let's do this. Let's implement this function. Function deploy ccpools, and this is external, and this is external. Let's do this. No? Yeah. Nice. So notice deploy ccpools, start the cross-chain deployment flow. It's get called by a user that wants to deploy new pool pairs. The user should select two networks. Select two networks. Select two networks. Then yeah, the contract should deploy pool on current network, and then to do this. Hopefully this is clear. This is clear, but needs to be first clear to me and then clear for others that are reading this, right? Select two networks and then deploy pool on current network and send CCP message to factory on other networks. And at this point, on the other network, this function will be invoked. And then here, well, this is actually to be implemented, right? So to do finish implementation, right? Okay, so good here. Just checking if I have 5 views, guys. I'm so happy about that. Thank you. Let's keep going. Okay, so select two networks. That means that the param network source, well, actually destination network. I think for now this is the only parameter I want to pass, and this will be bytes or string. Let's do string destination network. Okay, sorry. My girlfriend was asking me if I wanted some lunch or not. I said yes, of course. So destination network is actually should be destination network ID. So destination network ID, yeah, makes sense, and not maybe a string. Maybe bytes. No, or uint 256. Yeah, just doing 256 for now. Maybe let me check one second, one thing. Network ID data best data type for network for chain ID. Oh, chain ID. This is interesting. I didn't know that. Ethereum networks have two identifiers, network ID and chain ID. Although they often have the same value, they have different uses. For most networks, including mainnet and public testnets, network ID and chain ID are the same, with the network ID defaulting to the chain ID, as specified in the Genesis file. Chain ID equals 1981, for example. Okay, it's always the same. Okay, cool. But yeah, we'll just leave it. Uint 356. I have some error. I need to solve this, otherwise it's getting super messy. Sì. Ok. Uint 256. Come on. Okay. Okay. ID of destination network. This is not identifier not found or not unique. Maybe I will import this. Client. Oh, great. Again, CCP contracts. Using contracts, SRC. Okay, let's do contract. I'm trying to just fix this. I can't. ccip contracts. Oh, come on. Libraries. Why? I have another problem here. Come on. lib ccip contracts src v8. All right, v8. No, v8 ccip. That's correct. And then I want to put this pool factory ccip and then contracts ccip. And then without this, then vengo a tavola dopo. Okay, now it worked. ccip libraries. It doesn't work. ccip interfaces. Okay, into ccip libraries. It doesn't find the ccip content. ccip libraries client. Okay, of course, client. Oh, nice, it worked. Oh, thanks. I need to EVM message. Undeclared identified, of course, because I copy paste in a bed. I don't know why it was only message. Okay, any do EVM message. Should be nice. Yes. Okay, he likes it. Oh, other problems. Full factory. Try to close this again and reopen it. I'm just not ready for that. Okay, no, what did I do? Okay, I need to pass something here. Ok, ccipReceiver, ownable. Sì, dopo vengo, amore, un attimo. ccipReceiver. ccipReceiver, constructor, router. Of course, I need to pass the router in. address ccip router. ccip router. Makes sense. Need to understand which router should I pass in. Again, these problems. Oh my god. Okay. ccip receiver. Okay. So deploy ccipools. We were here, right? So one, select two networks. Destination network ID. Deploy pool on current network. Okay. Internal. Private. Deploy ccipools. The function deploy pool internal for now, and then just do new, yeah, return. We can just return the address, correct? Returns address. Cross-chain pool equals new cross-chain pool. What the hell do we want here? As cross-chain pool with the constructor, we want underline token and name. Makes sense. So we want to pass IERC20 underlying token and string name. Okay, so just pass it here this way and then return address of pool. Correct? Yeah. Okay, I need to import IERC20 here. Thank you, Foundry, to be so bad. Okay. So this will deploy the pool. At this point, deploy ccipOol will take another parameter, which is string pool name. String pool name. Yeah. Pool name. Name of pool. Pool name. Okay, and then deploy pool is internal, so we call deploy pool. And we return this. External returns, and we should also emit an event. Deploy pool. Oh, yeah, we need to pass underline token. C20 underline token and pool name. Pool created, and I want to the address of the pool. Uguale address of pool. I think this way I can save some gas somehow. Maybe not doing the conversion is helpful. Okay, pool address equals address pool created, pool address, and then maybe I can get this up. Okay, maybe we'll do it later. Okay, I think for now is enough. Yeah, I need to create this event, error events, event pool created, address indexed pool. Yeah, and then yeah, string pool name. What is this? Memory. Of course, I always forget about that. And then this is not used, but it's okay. Okay, I'm gonna get some lunch break and then I will be back. Okay, guys, I'm back. I'm back, and I'm going to keep doing this pool factory. Let's see if today, by the end of today, I think I still have a couple of hours left. I can integrate CCIP successfully, and I can call a function to deploy to contract in two different networks. Okay, so I have this factory. have deploy pool. Okay, so where were we at? Deploy pool. So you should pass an underlying token and a name, and the cross-chain pool should be deployed, and the event should be emitted. Okay, maybe I can emit this. Okay, I'm gonna return this, deploy ccipOol. Okay, let's start a little bit with the unit tests. Again, I need to do the same thing of yesterday. I'm gonna deploy cross-chain pool, deploy pool factory, right? Deploy pool factory. Okay, run. I'm gonna ask for this contract, deploy pool factory. What is it? What is the problem? Pool factory, deploy pool factory. Oh, of course, this is just pool factory. This is just pool factory. Pool factory returns pool factory. And to deploy this pool factory, I say that I need CCIP router. The CCIP router for now will be just an address, address of 1, I don't mind for now, and then return pool factory. Okay, this will be of course updated later on, and then I want to create a unit test, and I want to call it pool factory test. Pool factory test dot sol. Pool factory test dot sol. Maybe I will just cancel that. Yeah, deploy cross-chain. Yeah, pool factory, deploy cross-chain pool, and this is deploy pool factory from this script. Deploy pool factory dot s dot sol. Deploy pool factory dot s dot sol. Deploy pool factory. Why do I have an error? Deploy pool factory. Deploy pool factory. Deploy. Oh no, deploy. Deploy pool factory. Deploy pool factory. Deploy pool factory. Deploy pool factory. Should be nice now. Why do I have errors? Deploy pool factory. Deploy pool factory. It should be okay. Okay. No. Deploy pool factory. Deploy pool factory. And here deploy pool factory. Okay. Now it's okay. Set up, deploy, cross, deploy pool factory, deploy pool factory, deploy pool factory, and deploy pool factory dot run and pool factory test deployment, assert let me test this. Yeah, pool factory. I think if I go here and I do CCIP router internal, okay, assert assert not equal pool factory, the address is not an address of 0. Oh, come on. Okay, terminal, forge, test pool factory deployment, and this will change to test pool deployment. --mt. This is in pool factory, of course, because I need to do this equals public pool factory. Okay. Okay, so there is something wrong in our function, in the constructor ccipReceive router pool factory in the deploy script. Deploy pool factory is script run underlying. This is like, you don't need this for now. Address of 1 pool factory. Yes, pool factory, return pool factory. Pool factory has errors, but ccipReceiver, oh come on. Pool factory test. Okay. Okay. This was the error. Okay, passed. So the factory is okay. Okay, now let's see if how can I use this? Maybe this is what we need, because I need to chainlink-local. Chainlink-local is an installable dependency. It provides a tool that developers import into their Foundry and other script. This tool runs CCIP which means developer can rapidly absorb, prototype, and iterate CCP dApps off-chain and move to testnet only when they are ready to test in a live environment. Nice. The package exposes a set of smart contracts and scripts with which you will build, deploy, and execute ccip token, transfer, and arbitrary message on a local hard development node or Anvil development node. Chainlink-local also support fork nodes. User contract tested in chainlink-local can be deployed to test networks without any modification. Install the package. Import local simulator inside your test script, for example. Okay, there is more documentation. Let's see. The go-to place for developers who want to learn how to build application using chainlink-local. Chainlink-local is an installable dependency. Okay, this was the same. Next, architecture. Chainlink-local is a simulator for developers. Okay. User contract tested can be deployed to test network without any modification. Nice. Working with mock contracts on a locally running development blockchain node running on local host, and working using multiple fork networks. When working in a local simulation mode, the simulator pre-deploys a set of smart contracts to a blank Anvil network. Okay, so the simulator deploy some contract on Anvil or Hardhat, but in my case Anvil, and then expose details through calling this configuration. Okay, local forked mode. When working in a fork mode, we create multiple locally. Okay, this is so interesting. Multi-local blockchain networks. Okay, let's start with the local simulator mode. Okay, API reference, local simulator, that's all. Okay, this is the methods, examples. Cool. That's very nice. That's very helpful. Great job by the chainlink team. Actually, gotta be honest. Great job. Looks good. Let's start from the beginning. Let's install this. I think I already did. Yeah, I have. Okay, I have chainlink-local. Yes. Let's create a new test, and let's create chainlink-local test.solve. No, of course, chainlink-local need for this done. Remapping to chainlink-local. Okay, this. in my remapping, remap, no, in foundry.toml. Okay. Of course, pragmatolity. I need also these. Of course, everything is working, but I have problem here, and this is not working. There is some problem here. I have some problem with remappings, as always. Foundry.toml. Let's try to remove this this thing here, and let's try to remove this and this. Chainlink-local. No. So the mapping is chainlink-local. No, and this is wrong. Okay. This is chainlink-local, lib chainlink-local, and then what do we get here? Lib chainlink-local. No, you don't have local. No, local is that. Okay, lib chainlink-local, and then whatever, right? And then when importing a package becomes so hard, this is not a good sign. This is a big problem in Foundry. Importing packages, you don't know, it's very tedious, very boring. Okay, chainlink, no, definitely can't find lib chainlink-local, copy relative path, lib chainlink-local, chainlink-local, and here I want chainlink-local, and then oh, come on. No. Lib chainlink-local, src, ccip, but this is not working. How can I do that? Restart. Restart is always a solution. Okay, because this goes to src, chainlink local. Okay, chainlink local. Okay, this I can find this. So chainlink-local, src, ccip, simulator, that's all. Okay, now it's working. Okay, cool. Cool. Of course, this is undeclared identifier. And then what? Okay, I need to, the receiver is, I don't know, address of this, and the amount is 1E18. Oh my god. And then I would like to console log all of this. Okay, let's see if this works. This is the setup, and this is source router. What? Chain selector. Let's just do this. You know what? Let's do this. Let's do this. Yeah. Let's test function, test local, test chain link, test chain link local, public. Let's do this. Okay, this pass, and let's do just www. So this is chain selector. Let me log everything. Just curious, what is this? Why? What is this console log do? Just console log. Does it work? Why I have this? Don't really understand. He says, member log not found after argument demanded lookup in tile library console. Wow, what? Log int, log uint, log bool, log address, log bytes. It's just crazy. Why can I can't do that chain selector. Totally doesn't make sense, Foundry. And solidity, source router, not found or visible, source router. Let's see. I don't know what I'm doing. Doesn't make sense, of course. Why do I have this error? No, 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 no. I can just use it once. This is ridiculous. This is something weird. Log source router. I'm not even doing that. Local test 38 source router. This works. Destination router. Like, can be that this actually doesn't. Wrapped native doesn't work. Link token doesn't work. I'm sure that also those two guys won't work. Of course. But what if I command the first chain selector and then I do source router? No. It's like maybe I should do something different. Chain selector. Make this work. This should work. This pass. Doesn't make sense. Receiver and amount. token. And I'm doing something wrong for sure. What the hell? No, but it's a problem with console log. This is a problem with console log. Console to log, right? This is frustrating. Console to log, internal. It's crazy. It doesn't make sense. Let's go 1 second on ChatGPT. Configuration, public returns this, chain selector, return chain selector. IMOC router. Web9, wrapped native. I don't know, guys. As always in hackathons, you get to use things that doesn't work as expected, as documentation states. So this doesn't make sense. Like, why am I having problem logging this? Like, come on, is it my problem or what? Why am I not able to do that? Like if I log link token, like, oh, wait, console to log address link. What if I do that? That makes sense. Oh, that was the problem. Fuck. Okay, nice. Just understood. Oh, right. These are all address, right? These are all kind of contracts. So, yes, that makes sense. All right. I'm so dumb sometimes, but this was, yeah, tricky in a way. Maybe I'm a bit tired. I don't know. Destination router, source router. Yeah. Source router. Okay, so just for the, this will be helpful later on, so just doing it. Nice. Okay. Okay. Let's see. Okay, so chainlink-local is definitely working. Nice. Chain selector is this, source router is this, destination router is this, route native is this, link token is this. Okay. Link token, if I also want to do that. Link token equals link token at, there is something that is screaming. I don't know if you can hear it, hopefully not. Balance of link token. Let's see, link token balance. There is something which is screaming. Like, what's wrong with this guy? Like, guys, it's very loud this Saturday. It's very loud. In Italy, everyone is screaming. Link token. I have here link token. What is this link token? ERC 677 on create. On create mint total supply. Okay. Cool. Message sender total supply. Link token, total supply symbol, total supply, but how many decimals? And like, why? Link token balance of, okay, address this. insert EQ expected balance 118 1E18. Increase passes. Okay, works. Okay, so this is the test for chainlink-local. Okay, so maybe we can do a script. Because here I'm passing, okay, the pool factory, no, the script here, the pool factory, run. Okay, I can pass here address router. It's not used. Okay, address router. Pool factory router. Okay, and here, okay, it's not used. Okay, sorry. So local test. This will be like unit, and I will add another folder helper, and then I will do that, set up local simulator, blah blah blah, request link for setup, it's like function, function log info. Okay, and this setup this can be a script. Yeah, I want to do like a script, like a test script, test helper test script. Okay, this is run, let's call it this way. Log info, for now it's fine like that. The link, maybe I want to contract chainlink local helper script. Okay, as you can see, when I click this button, I get all the emoticon, all the emoji. Okay, chainlink-local helper is a script, and I have this, and I want to pass an address, and I want to, the address should be the one who should get the link. So user, I will just pass this user address user. Okay, so in the deploy constant pool. This can deploy pool factory in pool factory test setup. I can do, since the pool factory deploy pool factory script, come on, deploy pool factory script has the router, needs to get the router, deploy pool factory. I want to import chainlink-local test, no, chainlink-local helper. I have plenty of errors for this problem with Foundry. I have plenty of errors, come on. I will try to fix it offline, but this is very boring. Chainlink-local helper. So in pool factory I will import this from helpers helpers, and then chainlink-local helpers.sol. What? Oh, come on. Chainlink-local helper. Chainlink-local helper dot run. Address user. The user is, address this for now. This. Okay. Okay, and then I want to call chainlink-local helper dot source router. Should be something like that. Deploy pool factory now. Best router. Deploy pool factory. Yes, it takes the router. Okay. Pool factory does router. Okay, run. Let's see if this went through. Assert equal address pool factory. Okay, not equal. Okay. Empty test pool factory deployment. Okay, this. I should remove this. Console 2. Chainlink-local helper. This is not visible. Source router is not visible. Why is not visible? It is indeed source router. Let's try that way. It's not visible. Why is not visible? Is this public? Get source router. Oh, I need to first do this. Right, so now I can do chainlink-local helper run address this router chainlink-local helper source router, and I can delete this function, don't need it anymore. Expected one. Right, deploy factory router. Okay, this is deployed. Nice. Now what I want to do is how can I actually use this chainlink-local usage with Foundry, local simulator, get support exchange supporter, support new token, ccipLocalSimulator configuration. Okay, this is a test, an example of local simulator that's sending messages, I guess. Okay. Is a test, okay. Set up local simulator. Okay, ping, address, source router, pong. Testing from requesting from Pfizer. Let's see what is this ping pong, and yeah, this ping pong contract chain local test monk. 1, 2, 3 here, SRC ping and pong. SRC. Ping is ping. Okay. ccipReceive. Okay. Okay, this is an example of how to do that. Okay, I'm gonna get some little break and then come back. Cool. Yeah, in this little break I just had a closer look to the examples, to this ping and pong. Basically, what chainlink-local does locally, what ccipLocalSimulator does is instantiating a router, like two routers, and mimicking the mocking the behavior of chainlink, right? So you have iRouter client with the address of the router doing the CCIP send, right? And basically the CCIP send, for example, in ping, it just invoke the router in but in the same chain, of course, because you have only one local network, if I'm not wrong. So what happened here? Ping pong test set up ping. You give it the source router in the ping, and in the pong you give the destination router. And basically, I just don't understand how receive work. ccipReceive, message, ping. You see, you have a router here. ccipReceive does this, and basically this pong sends back a message, and this ping I thought I understood, but I didn't understand anything. Yeah, I think just, iRouter client. So this is Pong, for example, and Pong here is have the destination router. So destination router in Pong basically called send, the reply message, and ping receive this. It's not very well explained here. Where is chainlink-local? Chainlink-local documentation, examples. Okay. Ping pong test. You have ping and pong. You have chain selector. Ping send. Ping send, we go to ping, we call send, receiver, ambient code, receiver, data, token subscribe, free token. You create the message and then you call the router, destination chain selector, which is passed here, yep, and the message. So So ping send message here. The chain selector is the same. So in this is ping, and then pong of course will receive the message because it's okay. Now I understood. Now I maybe understood that. Let me try to explain it. So with local, like this color, local, chainlink-local. Finally understood. Chainlink-local has this contract called ccipLocalSimulator. ccipLocalSimulator.sol. Now I understood that. And this guy, this contract, has a constructor which accepts this ccipLocalSimulator has some configuration, has config, right? And what happened is that basically you need to you are in Anvil. If you are in Foundry, you are on Anvil, and then you have like two contracts, right? Let's give the example of ping and pong. Ping and pong. Ping will call like something like send message, which will have like the message and the chain selector. All right, and this send message will call pong, right? So this send message will call pong, and since ping and pong are on the same Anvil network, it will just work because this will call a router. This will call a router, which will basically call the pong receiver, right? Let's have a look at it again. So in the test, we call ping send. Actually no, this even better. Yeah, this is not the message, but it is the address, pong address, and then we'll with the chain selector. So if we go to ping, send has this receiver, right? It encodes the receiver data, which is hard coded, but we can add it as an argument, and then calls the router. Do this, don't mind, and the router will do ccip send with just destination chain selector and message. And I'm sure that this contract will basically look at the destination chain and look for the address. So this router, what it does is looking for address for Pong address on chain specified by selector. Okay, makes sense. Okay, so this is not doing any cross-chain stuff, but this is clever. I like it. So this thing is not doing any cross-chain stuff, but we need to. So okay, we have this router. Can we test our contracts? So this is send. Yeah, this is just send, right? So okay. I'm thinking about how to test our contracts here. So going to pool factory is ccipReceiver, deploy pool, blah blah blah, ccipReceive. This is the receive function, and let's create a send function. Looking at ping, let's try to send, like just copy all of these. Let's see if we can take something from that. This is an external function. Send. Yeah, this is send. This is external. I should call it after this. So I'm gonna do it in here, internal. So send deploy pool, yep, and send message, send ccip IP message, and so address receiver. Okay, and destination chain selector. So address receiver, notice, send a message cross chain to deploy a pool contract, cross chain to another factory to deploy a contract, right? Then param receiver, the other factory on the other chain, and then param destination chain selector. This should be a parameter. Yep. Okay, destination chain selector, the destination chain ID, basically. Well, chain link selector ID. Let's look into what is this doing. So client, message, client, receiver, the receiver. Okay, well, let's just send this thing, right? So data ABI encode ping, token amounts, we don't mind. Okay, extra arguments, gas limit, okay, fee token link. Then I have fee, iRouter client, get fee, iRouter client. What is this? iRouter client. I should import iRouter client. Let's see, iRouter client. Chainlink import. chainlink-local is from CCIP, right? CCIP. Contracts, SRC, V8, interface. No, don't have it here. So CCIP interface, router client. Copy relative path. Router client from CCIP. Oh my god. From CCIP interfaces iRouter client.sol. Let's see. Nice. Of course, this is all red because my VS Code doesn't accept, like sometimes it get crazy, and it just get crazy and doesn't recognize the, you see, doesn't recognize the mappings. But now, so iRouter client, I have it here, ccipReceive. No, I was doing the send function. Okay, iRouter client, get fee, destination chain selector, message. So this guy get the fee. Returns the fee. Okay, destination chain selector, message. Okay, fee, return execution fee for the message. Okay. Okay. Basically, the fee is the cost of the execution message on the destination chain. The cost for executing the message on the destination chain denominated in the fee token specified in the message. Okay. Link, fee token link. Where is this link coming from? Address link, yeah. Okay, so I need to add another. So address private fee token, address private storage, well, immutable, right? Immutable fee token, private immutable, right? Fee token, immutable fee token equals fee token address fee token okay, and this I will call it in here, and then fee router destination chain message, here's IRC20 fee token approve fee, okay, message ID okay, because here I have latest received message ID. I will do latest sent message ID, right? Makes sense. Latest sent message ID. Okay, send CCIP message. Let's see if it builds. Forge build. No, it's not building because the router is not specified. Okay, makes sense. Yeah, the router is not specified, but I have it here, right? I just CCIP router, CCIP router, do I need to internally immutable CCP router get router? I think I can do that. Get router. Address router equals get router. Should work, right? Yes. Perfect. Okay. Router client. Okay. So other notice. I like to put more notice. Notice the user who's calling that function should pay fees. Let's see if that builds now. New pool factory. Okay, yeah. Pool factory, deploy pool factory, router and link, right? Address fee token. Right, because pool factory now need a fee token. Okay, so deploy pool factory fee token script build in test here. I want the fee token router and then fee token chainlink-local. What can I get from this chainlink-local helper? Link token, yeah, makes sense. Link token. Link token. Like that. And fee token. I'm gonna do it here. Does it build? Okay, builds. I have different warnings. Use local variable. This expected balance. Okay, for now I will stay with that. Okay, but now it's kind of working. Let's see if the pool factory deployment work. Forge test -- empty test pool. Okay, test pool factory deployment. Pool factory work. Nice. Then guys, we are in a critical moment. Critical moment. We are in a critical moment. We want to deploy ccipools. Deploy pool is internal. Okay, so deploy pool, I'm calling that. So let's call it address deployed pool equal deployed pool. Okay, and then I want to send CCIP message, right? I want to call this function send CCIP message. It doesn't. Okay, this return the message ID. Actually, I don't need to return this external. This is not external. This should be internal. approve address router fee. This is kind of weird because I want the user to call this, right? For now, I want the user to pay, so he should do that. Okay. Or no, maybe the user will transfer token here and here. Maybe it's better. Yep. No. Okay. User will transfer token to this contract. Yeah, but okay, I don't know. Maybe the deployer will send fee tokens to this contract. Yeah. And also we'll add this in this. Okay. So where were we at? So send ccip message. Send ccip message is an internal function. And it has an address, which is a receiver, which is destination network ID, and is yeah, address receiver factory, right? And then destination chain selector, destination network ID, let's call it this way. uint 64, uint 64. This guy, basically, we need to do some check here, I'm sure. So get router, we need to do some review, but let's try if this works first and then we will do the review. So deploy ccipools now has this chain selector, the pool name, underlying token, yeah, this guy will change. For now, just this deploy ccipools. Okay, send ccip message. Okay, and then this receive will be invoked by the router. Last received message ID, this text data string, receive text. Okay, so okay, message received. Cool. This is internal and is override. Okay, that's fine. Pool factory test. Okay, function. This is crucial. This may be one of the last thing I will do today. before ending the live streaming, guys. 8 views so far. Thank you very much. Thank you very much. I know the last few hours were a bit more silent, but I needed to focus to understand this cross-chain interaction protocol. How is it? Interoperability protocol. I mean, they could have choose a simpler, more simple name, but okay. Test, send, and receive MSG public. All right. So now what I want to do is chainlink-local helper. Okay, so okay, in this contract, in chainlink-local helper, I want to just mint 1,000 link. Okay, so here I should, so pool factory is already deployed here, and I want to should I deploy? No. Yes, so I should deploy to pool factory. Pool factory source chain, pool factory destination chain. Okay. Source router, and this is destination router. Pool factory destination chain. You take source router and you take destination router. Cool. Fee token is the same because it's the same network. It will change a lot in the future when I do the 9 views. Thank you, so glad. Yeah, so fee token is the same, but likely will change. Of course, it will change a lot during the course. So now I have this deployed. Let's look at the example here. Yep. So it's deploying 2 contracts. Yep. And then, okay, the user, I want to found the contracts. I can do it here. Okay, send link to the contracts. So this contract already have 1,000 link, so let's send fee token. I'm gonna just this, need this. ERC20. Fee token. I should no. token, fee token, how is transfer, no? Transfer to value, let's transfer 10 E18, and 2 should be pool factory source chain, should be an address, right? Yeah, should be an address. It's okay. Source and destination will mint. We'll send link to the contracts. Let's see if so far so good. Did you mean pool factory? This is not equal. Pool factory. Oh yeah. Source chain. Pool factory destination chain. Oh, I'm just sometimes very stupid. Address this. Okay. Okay. Okay, this worked so far. Then going to pool factory, I want to call deploy ccipools. So this should deploy a pool and then send ccip message. So and to call this function. So this function is on pool factory source, right? Pool factory source chain dot okay, pool factory source chain dot deploy ccpools. I want to get the destination router. I want to get the uint64 chain selector equals the chain selector chainlink-local helper dot chain selector, and we'll just do this public. Yeah, love it. Chain selector. So chain selector, and then okay, pool name, just test pool. Dead pool. Dead pool. And yeah, then IRC20 underlying token. Where is it? Underlying token. Don't I have it here? Do I have it here? No. The Bible factory fee token. What is the underlying token? Should I create it? Deploy cross-chain pool underlying. And deploy cross-chain pool underlying. Let's do this. Deploy factory test. Blah blah blah. Yeah, I need to copy also this. And then underline new ERC20 mock. I will do a bit of cleanup, but for now I don't mind. Okay, underlying token. This is the underlying token. And then receiver factory. Receiver factory is the address of the factory. So pool factory destination chain. Okay, so pool factory is here. Okay. Deploy ccipools. Okay, and then check for emitted for, then pool factory, when it sends CCIP message, it should do last send message ID. No, this is send, this is receive. This as received text. Get last message, blah blah blah. So pool factory destination chain should call this, and this will return this. Text factory. Oh my god, too many errors here. So subscribe to Fabrizio Gianni 7 Chan YouTube channel. So last received text assert EQ last received text equals this guy. Let's see. Last received text and declared identifier, of course. Last received text is string. Oh, no way, it worked. Let's see. It worked, guys. Oh my god, I'm so excited. It worked. Full-fact destination chain. It actually worked. Actually worked. No way. We have console here, yeah. Console.log last received text. No, guys, this is so exciting. Yeah, wow, it worked. I managed to send a message to the other contract and to test locally in my testing environment. This is great. This is actually very good. Oh my god, I'm so excited, guys. I'm so excited. I'm so excited. Okay, I think for today that's a wrap. Yeah, today this is a wrap. Yep. And Yeah, so let's have a little bit of recap. What I did today is what did we do today? 9 views. Thank you guys. So today we just decided how to implement the deployment of different pools across different blockchains. So we have, this is a bit messy, but we have, yeah, maybe this is kind of okay. We have a factory deployed on each network that deploys couple of pools, right? That deploys couple of pools in each network, right? So the user will go in the network and will send a cross-chain message to another factory, and will deploy a pool on the starting, on the source network, and on the destination network. And when those pools are deployed, then we will be able to do the bridges. So this is great. This is actually great progress. Today I went through the CCIP documentation and CCIP examples, and I implemented, I used CCIP chainlink-local to simulate locally my CCIP stuff. Tomorrow, what I'm gonna do is to probably will be doing the same, but with real networks. So I will try to fork 2 networks. I will try to do the same, and maybe in private I will clean up a little bit the code, because I think it's getting too messy, because CCIP libraries is very it's very complex. It's not easy to understand what you are doing. It's very easy. It's very hard to test things. Like, you need to understand really how it works, and it took me a couple of hours, considering also that my brain is very small. Yeah, maybe a better developer would have spent less, but I'm kind of dumb sometimes. Okay guys, so from my side for today is all. I will come back probably tomorrow. Usually in the morning I will send an advice on the Discord and the hackathon Discord, on Twitter. Yeah, follow me on Twitter. My name on Twitter is, yeah, it's not very I'm gonna write it, it's better. Okay. Twitter. Twitter handle testo. Okay. $49. Okay, this is my Twitter. Yeah, this is my Twitter. And then, yeah, this is my Twitter. Fabrizio Gianni 7 on Farcaster. And Telegram as well. Okay, I don't know what's going on here. Okay, so guys, it's been very nice today. Yeah, coming back tomorrow. Tomorrow we will definitely go on with the chainlink ccip infrastructure. We look how to use it across 2 forked nodes. This will be crucial for the success of the project. So tomorrow and Monday will be really fun days. Today I'm very satisfied with what I achieved, and yeah, see you tomorrow, guys.